finals paper. This is for 80 marks. Section A, as you know, is for 40 marks. Question 1 is MCQ. Now this one is from your chapter 1. What is 1 micron? 1 micron is 10 to the power how much? Correct? And you have to convert it into what? 1 angstrom. How much is that? 10 to the power minus 10 meter. Now this conversion many children don't like, so you must look at this as 10 to the power minus 6 into 10 to the power minus 4. If you still have a problem with this, I have a series of interconversion of these type of uh, conversions, and they are on YouTube, so just go through the conversions in case you need more practice. Okay, now can you see over here 10 to the power 6 meter means what it is? Can you see that? So in place of that, what you'll write? 10 to the power minus 4, and in place of this, what you'll write? Micron. Understanding? So 1 angstrom is equal to this. So 1 mu, that is micron, will be equal to this goes this side, so it becomes 10 to the power 4. Did you understand how the conversion went?
Yes, ma'am.
Okay, so which one is the correct option here?
Option C.
The least count of the meter ruler has 0, and then this is centimeter, and the smallest division is 1 millimeter. What is 1 millimeter? 1
0.
millimeter will be equal to, it is 0.1 centimeter, yes?
Yes, ma'am.
It's centimeter, it can't be 1 meter, right? So it is the, again, option C, yeah? Body projected up with initial velocity u reaches maximum height h in t seconds and then comes back. The incorrect statement. So we have initial velocity u, final velocity will be 0 because it goes to the highest point. This is h, and then it comes back. The time taken is t, so t1 for going up and t2 for coming down. Correct? Total time will be t1 plus t2. Let us see what they are saying. Distance covered is 2h. This way h and this way h, so it is correct, but they want incorrect, so we can't take this. Final velocity will not be u, it will be v, which will be 0. Acceleration is 0. 1 minute. Final velocity, oh, final velocity when it comes back over here, yes, it will be still here, it will be v, then it comes back over here, it will be u, is correct, so no. Acceleration is 0. Acceleration is going to be, when it is going upwards, it will be negative g, when it comes down, it is positive g. Displacement is 0 is correct, so you cannot take that. So the incorrect option is this. Acceleration is not 0. If acceleration is 0 means I will go with the same velocity. Now initial velocity became 0. That means there is decrease in velocity. Obviously acceleration is not 0. And when it comes down, there is increase in velocity. So acceleration is again not 0. So this is the correct option. So far your teachers have given C as the correct option. Let's see if the next one is also C. Displacement time graph for a freely falling body. No, acceleration time. If it is acceleration time graph, it will be like this. This is your x-axis, this is y-axis. Freely falling body. Now freely falling body will have initial velocity 0. Time is 0, initial velocity 0, acceleration will be 0. Correct? But the acceleration will be, how much is the acceleration? Freely falling body, it will be 10 meter per second square. Correct? So it will be like this. Correct or no? Acceleration will be constant, no?
Yes, ma'am.
So Will it be straight line parallel and above x-axis? Yes. Straight line inclined? No. Inclined means acceleration is increasing. We have g remaining 10 meter per second square, straight line parallel, and below this one means it will be retardation, correct? This one will be minus 10. So not this one. Straight line inclined to y-axis? No. So correct option is which one? Parallel and above. Understanding how to think. The object falling freely from rest reaches the ground in 2 seconds. The acceleration due to gravity is 9.8 meter per second square. Velocity of the object on reaching the ground will be. So freely falling body means initial velocity is how much? 0 meter per second. Time is 2 seconds. Acceleration due to gravity. Yeah, thank you. So G is 9.8 meter per second square, and the velocity, final velocity, is how much? So I will say V is equal to U plus AT, but freely falling, so it will be 0 plus 9.8 means 98 upon 10 into time is 2. So how much will that be? 98 into 2 will be 196, 19.6. Can you see that? Yeah. So again, C option. Let us come to the next one. Two bodies A and B, same mass, moving with velocities this, then the ratio of the momentum. Now P1 is to P2 will be equal to mv is to mv. Okay, now if the body A and body P have same mass, then m and m will be same, which will get cancelled. But V1 is 2V and V2 is V. Tell me what is the correct option?
Option C.
Correct. Now your teachers like that C option. Pressure P on the top of a dam and pressure P2 at depth H inside the water. Now remember, the dam wall is going to be built like this. So if this is P1 and if this is P2, tell me, more the depth, more will be the pressure. So P2 will be greater than P1, yes? Yeah? So pressure P1 at the top and pressure P2, how are they related? P2 minus P1. P2 will be greater, no? So P2 minus P1 will be equal to H rho G. Which one option?
Option D.
We come to the 8th one. Atmospheric pressure on the Earth's surface is P1 and inside the mine is P2. They are related as on the Earth's surface. Remember, on the Earth's surface, this diagram I had told you to know by heart, correct? At the equator, this distance from the center is more, this distance from the North Pole is less. So G this way decreases. Okay, G decreases. So gravity decreases. Pressure on the surface P1. How are we going to look at this? Pressure is not connected with G, right? Pressure is going to be equal to H rho G. So from the surface, if you go inside, the air column is going to be more, right? So inside will be more, P2 will be more. Agreeable to you?
Yes, ma'am.
But what are they giving you the option?
Option C.
P2 is more means P1 is less, correct? Two balls, one of iron and the other one of tin, experience the same upthrust when dipped completely in water. Now same upthrust. Uh, Same upthrust means it will be same. Uh, what is upthrust equal to? Upthrust equal to loss in weight, which is equal to the weight of liquid displaced by what?
By the body.
Immersed part of the body, है ना? Immersed part of the body, correct? Which means if the immersed part is the same, that means volume immersed must be same. Understanding? So both of them have equal volume, equal density, equal shape. None of the above. They, when dipped completely, if they are completely dipped in water, then volume immersed will be the volume of the whole thing, right? So both will have equal volume is the correct option. Understood?
Yes, ma'am.
Understood, right? This is easy. What you'll do? Minus 273, correct? Degree C. Is this minus over here? Is it written over minus?
Yes, ma'am.
Yeah, no? It's not a stain on my laptop. No, no. The food chain begins with photosynthesis, right?
Yes.
Now this is easy. 5 feet away in front of the mirror, how far from her will the image be located? 10 feet, right? Object distance is 5, image distance also 5. Easy.
Yes, ma'am.
Ratio of two sound waves is this. So lambda 1 is to lambda 2 is equal to 3 is to 5. The frequencies. The frequencies and wavelength, how are they connected? Frequency is inversely proportional to the wavelength. So f1 upon f2 will be equal to lambda 2 upon lambda 1. Now why do I say this? This is because v is equal to f lambda. So if the velocity remains the same, then f1 lambda 1 will be equal to f2 lambda 2, which means f1 upon f2 is equal to lambda 2 upon lambda 1, which means 5 upon 3. So it will be this option. This is easy. Insulate of electricity is which one? It will be silk. Okay. Human body can get a shock, so it is a conductor of electricity. Copper is a metal. Acidulated water is an electrolyte, so they will conduct electricity. Silk will not. Uniform magnetic field. What happens to the field lines? They will be parallel, equidistant. So that is again option C. So I think it is kind of straightforward paper. Fundamental unit learning work, nature of fundamental units learning work, define. Can you see all this is learning work? You can do on your own. Now they are telling you first 30 minutes velocity is this, next 40 minutes the velocity is this in the same direction. Calculate the total distance traveled. So you will find d1 equal to what? Speed 1 into time 1. What will it be? Tell me. Speed is 30 kmph. They are giving all kmph. So I don't have to convert it into a meter per second. So 30 kmph multiplied by 30 minutes means half an hour. So that will be 15 kilometer. What will be your D2? Tell me. Again the same thing, but it will be 40 speed and 40 minutes means 40 upon 60. Understanding?
Yes, ma'am.
So this will come out to be how much? Distance 1, 2, 3, 7, 2, 20s. 80 upon 3 kilometers. है ना? So total distance traveled will be equal to total distance d1 plus d2. How much is that? 15 plus. So if you take LCM, 15 3 is 45. 125 upon 3, 3 4s, 3 1s, 2/3. So 0.67 kilometers. Okay, so this is the total distance traveled. Now average velocity, what will you say? Average velocity will be total distance upon total time. Correct or no? Total displacement will write, but don't say distance because velocity. So what you'll say? Total displacement upon total time. So total displacement will be how much? 125 upon 3. And total time is how much? 30 minutes and 40 minutes. Means 70 minutes. So 70 upon 60 hours. This is kilometers and this is hours. So that will come out to be 125 upon 3 into 60 upon 70. Calculations are little irritating, but it's alright. 250 upon 7. That is equal to, make it into decimal and write the answer. Okay, so otherwise it is just a straightforward learning paper. See here, two important characteristics you have to learn. What do the following indicate the barometer in a barometer? Gradual fall, sudden fall, again learning work. Correct or no? Now this is again density of the ice is this, that of sea water is this. Find the total volume of iceberg which floats with the, find the total volume which floats with this much above water. So what you will say, let total volume of iceberg, we'll call that as x centimeter cube. Now remember our formula has volume immersed. So volume above water is 800 centimeter cube. Therefore volume below water means submerged is going to be x minus 800 centimeter cube. Okay, then which formula are we going to use? We are going to say relative density of ice will be what? Density of ice upon density of water is equal to small v means volume immersed upon total volume. Understanding? Volume of ice is given as 0.92. So 0.92 gram per centimeter cube upon 1.025 gram per centimeter cube will be equal to, it will be x minus 800 upon x. You understood?
Yes, ma'am.
Is it doable? Now let us remove the decimals. We don't have much place here. So 92, can I make it as 920 here upon 1025? And that is equal to x minus 800 upon x. Oh, should I reduce this? 5 ones remain 4, 5 eights and 5 fours. Here it will be 5 twos, 5 zeros, 5 fives. Is it? No. So it will be 184x is equal to 205x minus two zeros, 8 fives 40, carry 4, 8 to 16. What did we get? 164,000 is equal to 205x minus 184x. Can you see little irritating calculations these are? So you will get some fraction as the total volume. Will you be able to handle it? Tell me. Write
Yes.
your answer in decimal. So we don't have to do each and every question. We have to just see how it has to be done. Now can you see from here, this is from which chapter? This is heat, no? So this again learning work. Two advantages of wind energy for generation of electricity, again learning work. Two advantages and two disadvantages also you must learn. For all these energies, learn the advantages as well as limitations. Can you see again learning work? Yes. Name the mirror which always produces upright and virtual image is which one? Which one?
Convex.
Convex, correct. Virtual image and upright. Now, do you know even plane mirror?
Yes, ma'am.
So I am wondering what the teacher's looking for. Always upright, and I mean, when I look at myself in the mirror, I don't see myself upside down, no? So what this question should have been? Upright. If they say diminished, then I will say convex. Understanding?
Yes,
But
ma'am.
only upright and virtual means plane as well as
Convex.
convex. Understanding? For
Yes.
which position of the object the image formed for concave is magnified and upright? When the object is between F and sorry, yeah, F and P, correct or no?
Yes, ma'am.
So you have to know all the ray diagrams. What are the effects of changes in temperature and pressure on the velocity? Can you see again, this is a learning work. You have to learn these things by heart because majority of the stuff they are asking you is not application questions. They are asking you to learn up the work. So learn up everything properly, okay? Two conductors A and B are joined with copper wire. State the direction of the flow. So if they say that your A is positive and B is uncharged, means positive, negative, both. So which one has got more concentration of electrons? This one. So flow of electrons will be from B to A. Understanding? But if it is A is negatively charged, this is negatively charged, and B is uncharged, means both equal, more concentration of electrons will be A to have, so it will be from A to B. Two advantages of electromagnet, these are again learning works. Yeah, the strength of the magnet can be increased or decreased, the polarity can be reversed, correct or no? So you can write all those. Now section B, any four questions. Let us see section B. How is it like? Instrument has 25 divisions on the vernier scale which coincide with 24 divisions in the main scale. 1 centimeter of the main scale is divided into 20 equal parts. Find the least count. Okay, so uh, what do we have to uh, know the least count as? What is the least count of vernier? What is the formula? You'll have to now, because you are full of the other subject paper that you had today, you will take some time. So open your textbook and check. Are they saying that it is the one What is the formula?
Value of one main scale division
Ah,
upon number of
one
divisions
main
was
scale division upon
total number of divisions on vernier scale.
So number of divisions on vernier scale, correct or no? So what is the main scale division? Main scale division has got 1 centimeter into 20 parts. So you will say 1 centimeter has got how many? 20 divisions. Correct or no? That means 10 millimeter has got 20 divisions, which means 1 millimeter has 2 divisions. Correct? Which means 1 division is going to be equal to half millimeter, yes?
Yes,
So
ma'am.
I'm writing 1 main scale division as 0.5 mm. Yeah? How many divisions on the vernier scale? 25. Correct? So that will be equal to 5 upon 10 and here 25. So 5 ones and 5 fives. What am I getting here? 1 upon 5 into 10 what? Millimeter. 1/5 means 0.2. So 0.2 upon 10 millimeter. So if they are giving us 1 centimeter, so we will write, I don't have space, so I'll just continue here, equal to 0.02 millimeter. So if I want it in centimeter, what I'll do? Divide this by 10 again. Did it make sense?
Yes, ma'am.
Yeah, understood. Now let us come to the next part. What are they saying? The length of seconds pendulum on a planet is 2 meter. Find the acceleration due to gravity on the surface of that planet. What does this mean? If you are going to make 2 columns, first and the second. So this will be our Earth and this will be the planet. Okay? And they are telling you it's a seconds pendulum. What does seconds pendulum mean? That the time period goes tick tock, 1 second here, 1 second here. So the time period here, T1, is going to be 2 seconds, but the length on Earth, it is 1 meter, correct? Hello?
Yes, ma'am.
But here they are saying it is a seconds pendulum, so the time is 2 seconds, but the length L2 is 2 meters, they are saying. And they are saying find the acceleration due to gravity. So there will be G1, which is equal to G for Earth, and they are saying find G2. Now G1 we can take as 9.8 also. What is the connection between time period and this? We have T equal to 2 pi root of L upon G, yes?
Yes,
So T1 upon T2 will be equal to under root what? L1 upon L2 into G2 upon G1. Understanding up to there?
Yes, ma'am.
So T1 is 2 seconds, T2 is 2 seconds, which is equal to under root 1 meter upon 2 meter into G2 we do not know, and G1 is, let us say, 9.8. Okay, this got cancelled. Okay, so if you square, you will have 1 equal to 1 upon 2 into G2 upon 9.8. So our G2 comes out to be, this goes that side. So how much is it? 2 into 9.8. Understanding, no? How much is that?
19.6 meter per second square.
And what you'll write over here? This is G on planet. Of course, you will say acceleration due to gravity rather than this. Okay, we don't have time. We are going to move fast. Velocity of body is continuously changing. Can its speed remain constant? Yes, in a body in a circular motion. Correct or no? What happens? Body in circular motion, the velocity each time the direction is changing, but so it becomes a variable velocity, but speed is constant. Correct? You
Yes, ma'am.
remember this circular motion? This is
Yeah.
important from class 10 point of view also. Is it possible if the body is changing, can the velocity, if the speed is changing, can velocity remain constant? No, because magnitude is changing, no? If magnitude changes, even if direction is the same, velocity changes, correct? Understanding? Writing it in short. Is it possible for a body to have constant speed in accelerated motion? Accelerated motion is when the velocity is variable. Therefore, it will be again circular motion. Yes, it is possible. Okay, give an example, circular motion. Circular motion has speed constant, but velocity changes. If velocity changes because direction changes, it's an accelerated motion, but the speed is constant. Okay, now let us look at this. Lift generated from, no, what did I write? What did I read? Lift gets accelerated from rest to speed of this. So initial velocity is 0 meter per second. The final velocity is 72 kmph. Now in the formulas, v is equal to u plus at or whatever, we will have to make sure, see this is given seconds and this is kmph and this minute. So we'll have to make it as 5 upon multiplied by 5 upon 18, 18 ones and 18 fours. So it will be 20 meter per second, and the time t1 is 1 upon 12 minute. Means how many seconds, tell me? Did you agree with that much?
Yes, ma'am.
So then it moves uniformly for next 30 seconds before coming to rest at the topmost story building in 8 seconds. So draw velocity time graph. Velocity time graph. What will I have to do here? Velocity, I will show the arrow here and I'll write meter per second. This is the first thing. You must mention the axis, origin, this is x-axis, and this is time. So we'll write time in seconds and I'll keep this ready. Now it is starting from rest, means time is 0. It is going how much? 5 seconds, then 30 seconds. So 5 seconds, then 30 seconds, then 8 seconds. Okay, shall I write it like this? 5, 30, and this will be next 8 seconds, means is it uniformly for the next 30 seconds before coming to rest at the topmost story in 8 seconds. Okay, so this is 30 and then these are the next 8 seconds. Tell me, if it is accelerated motion, it is going to go to how much? 20 meter per second. It is going to go here. So this will be the initial part. Then uniformly means your velocity is the same here. Then it comes to rest, means velocity is decreasing. Did you understand what has happened?
Yes, ma'am.
This is good enough. Tell me fast. Yeah. What is the acceleration of the lift? The acceleration of the lift is here. So we'll call this as A, B, and this is C. Okay. So for this is your A part. For B part, acceleration, what you'll say, using OA, acceleration will be equal to the slope of what? OA. What is the slope of OA? Delta y upon delta x, correct? What is slope defined as? Delta y upon delta x. How much is delta y from here to here? It is 20 meter per second. And how much is this from here to here? 5 seconds. So that is coming out to be how much? 4 meter per second square. Did it make sense to you? This is your answer B. You're with me? Now for a C, how will we write for C? What is the retardation? Which part you will use for retardation? Using BC, no? Correct? Using BC, this is retardation, right? Hello?
Yes, ma'am.
Now using BC, that there is another way of, either you could say slope or you could say initial velocity for BC is 20 meter per second, correct? And final velocity is how much? 0, no?
0
meter per second, yes. And how much is the time? Look, isn't it 8 seconds? So if I want the acceleration, what will I say? A is equal to V minus U upon T, which will be equal to, tell me, V means 0 minus 20 upon 8. This is meter per second and this is second. How much does that give you? 4 2s and 4 5s. So minus 5 upon 2 meter per second square, correct? Hello? Which is minus 2.5 meter per second square, correct? But
Yes.
what are they saying? Retardation. So will you write A? What you'll write after that? Therefore retardation, tell me. Retardation equal to minus acceleration, means minus into bracket minus 2.5, which is equal to 2.5 meter per second square. Understood how this was done?
Yes, ma'am.
The height of the building is the total distance covered, will be the area of this. Understood? So for D part, I will write here the height of building is going to be the distance traveled, correct?
Yes, ma'am.
Distance traveled. For velocity time graph, it is going to be the area of graph. Area of graph. Area of graph. Area of graph, no, area of figure between graph and x-axis. Correct? Which means that will be area of the trapezium. Understanding? What is the formula for area of trapezium? You just finished maths today. So half into bracket what?
Sum of parallel sides into the distance between them.
Means height. Correct? So that will be half into bracket from here to here is, oh, 1 minute. The next 30 seconds, sorry, mistake. You know what this should be? 35, no? From here to here, 30. Can you see that? This is 35. and 35, and this is not 38. 8 more means 43 seconds. Understanding, right? Oops, I made a mistake. See how I double checked now? You understood now my mistake? Yeah. So from here to here is 30, correct? Plus from here to here is how much? 43. Multiplied by how much is this vertical height? 20. So 2 ones and 2 tens. That is going to be equal to what? 30, 73. 73 into 10. So 730 meter. Understood how this was? Yeah? This was a little application here, but I think it was okay. Let us come to this. What is she saying? There is a book of so much mass. Find the force. The force exerted by the earth on the book is going to be the weight of book. Understanding? Weight of the book means what? M into G. How much is M? 6 kg means 6 upon 10 kg. Multiplied by G is how much? 9.8. Correct? Meter per second square. So that will give us whatever it will be Newton. Understood?
Yes, ma'am.
Now here, the force exerted by the book on the earth will be the reaction force, which will be same as the action means weight of book. So whatever you written here, the same thing, Newton. Only thing is that, what is the difference between this one and this one? Are they different? When we have the earth acting on the book, that means if there's nothing to keep that book on, it will fall towards the earth. So this will be the direction. What you'll have to write over here, tell me, vertically downwards. Understanding? And the reaction force for the second part, what you'll say, vertically upwards. Understanding? Are you with me? What is the reaction force from her palm on the book? Correct?
Yes, ma'am.
Under what condition the book is in equilibrium? Equilibrium, is it there in your textbook? Only when the reaction force is going to be equal. Supposing that 0.6 kg book is too heavy for her, then her palm will fall down. No? Let us say in place of 0.6 kg, it was 6 kgs of books on one palm. Will she be able to support that? Difficult, no? Only on one palm? Correct or no?
Yes, ma'am.
Yeah. So remember that if the action was too much and she cannot provide, so under what forces book is in equilibrium? Equilibrium, the algebraic sum of the net force is 0, then it will be equilibrium. But it is not part of your syllabus, no?
No, ma'am.
So just leave that. It's not there in the textbook. All right? Under what forces? Let us come to the next one. The railway locomotive with mass 80 tons. What is the mass 80 tons means 1 ton is how many kg? Check the book. Is it 100 kg? Is it 1000 kg? Quickly turn the pages, tell me.
1000 kg.
Very good. And accelerates is 2 meter per second square. What force? The force is equal to m into a. Is it doable? Substitute and you'll get your answer in Newton. Can be done?
Yes, ma'am.
Suppose a planet of half the mass of Earth and half the radius of Earth exists. Find the acceleration due to gravity on the surface of this planet. Now this is with your formula. What is the formula? F is equal to what? G into, correct or no? Do you remember this formula? On which page is this formula?
Page 85.
Okay. So, is this the correct formula have you written?
Yes, ma'am.
Hmm?
Yes, ma'am.
Okay. So, you are going to have case 1 and case 2. So, this will be for the Earth and this will be for the planet. Okay. Half the mass of the Earth. So capital M1 and how do I half the radius of the Earth. Suppose a planet. So if this is M, then M2 is M upon 2. And if this is R1 is R, then R2 is how much? Half the radius. Correct? Find the acceleration due to gravity. How do we go with this? Acceleration due to gravity is small g, no? What have they given about small g over there?
9.8.
That is here in the formula.
Small g is big G m upon r square.
Small g is equal to, tell me?
G m upon r square.
So we'll have to use this formula, not this formula. Understood, no? Here we are using gravitational constant and then the force of gravity, yeah, na? Understood?
Yes, ma'am.
So if we do this, then tell me what we will have. G1 upon G2 will be equal to G gets cancelled and M1 upon M2 because directly proportional to this mass and R2 square upon R1 square. Did you understand what I did over here? In the numerator means directly proportional, in the denominator means inversely proportional. Did you understand this part?
Yes, ma'am.
Okay, so G is 9.8 and G2 you have to find will be equal to M is here upon M upon 2 into R2 is R1 R square upon 4 upon R square. So 9.8 upon G2 is equal to m into 2 upon m into r square upon 4 into 1 upon r square. So G2 is equal to 2 into 9.8. Okay. This made us think a little bit, no? Initially we thought of this, then we said that no, we need the relationship between small g. So small g and big G, remember these relationships, important. Okay, they will ask you something like this, because even in your maths paper they asked certain questions which were a little irritating calculations. Let us look at this. YouTube is first filled with mercury, water is added to one arm and oil is added to the other arm. Find the ratio of water and oil columns so that mercury level is same in both the arms of the YouTube. Show it this way so that it's easier for you to comprehend. They are saying that the mercury level is the same. Okay, and they are having water in one arm and oil. Water has more density. This is water. So more density means less volume will apply the same pressure as the liquid oil. Did you understand this? This is density equal to 10 to the power 3 kg per meter cube. But oil, the density is less. If the density is less, I will need more volume of it so that it will have the same thrust here. Did you understand?
Yes, ma'am.
Because the level of this is mercury. Okay? So I will say pressure due to water will be the same as pressure due to oil. Correct or no? So I will have H rho G of water equal to what? H rho G of oil. Agreed? Agreed?
Yes, ma'am.
Can I cancel G and G because gravity is the same here also, correct?
Yes, ma'am.
Now they are saying that ratio of water and oil column means they are asking H1 upon H2. So H water upon H oil will be equal to, here I will have density oil and this density water will come here. Did you understand what I have done?
Yes,
So
ma'am.
that is 900 kg per meter cube and this is 1000 kg per meter cube will get cancelled and the ratio of the heights will be, so ratio of the columns, water and oil columns. Understood?
Yes, ma'am.
Yeah? Okay. This is again explain the this thing learning work. This again learning work. They had the same thing where the observations came earlier. They asked about the weather, and now they are repeating this. Draw the approximate graph to show this variation. This again is learning work. Yeah, so lots of work you'll have to just learn by heart. Okay, everything. Their main thing is they are asking you to learn things by heart. Okay, for your school. Some schools will give application question based. Your school is not asking that. They are giving you same block of wood is floating everywhere. What does same block of wood mean? Its weight will be the same and volume also will be the same. Agreeable to you? Hello.
Yes, ma'am.
Now, which liquid has highest density? The one which will have most density will offer most upthrust, means push it maximum up, means which one? This one, no?
Yes, ma'am.
Can you see that? Yeah. So what will be the reason for this one? Liquid B has max density since provides max upthrust, that is volume immersed is less. Correct or no? If the upthrust is more, volume immersed will be less. Look at this volume immersed. Now tell me which one is the lightest. Which
B.
one is the least density? B, no?
A.
What will be, sorry, A. It will be A, right? And what you'll say, since it provides least upthrust because maximum volume is immersed. Correct? You're with
Yes.
me? Okay. Now relative density of, what is the density of silver in SI unit? It will be 10.5 into 10 to the power 3 kg per meter cube. Correct?
Yes,
Yeah?
ma'am.
Huh. So you will see it's not really a bad paper, but lot of learning work. Weight in air, weight in liquid, find the volume of solid. What will be the first thing to write? W air. How much is it? 30 GF. Then we have W liquid is 26 GF. They are saying the relative density RD of liquid is 0.8. Find number one, volume of solid. Okay, now volume of solid, for that I will say the upthrust in liquid is going to be equal to loss in weight in liquid. Correct? Which will be W air minus what? W liquid. Correct? Which is equal to 30 GF minus 26 GF, which is equal to 4 GF. Correct?
Yes, ma'am.
Now, remember upthrust formula is V rho G. So, what will we say? That the upthrust is equal to V rho G that is volume of the solid into density of liquid into G. Agreeable? So 4GF is equal to Vs rho Lg. Correct? Now, if I remove this G, I will have 4 gram equal to volume of the solid into the density of the liquid. Now, RD is given, so I'll have to mention therefore rho liquid will be equal to 0.8 gram per centimeter cube. I'll have to mention this here, otherwise I may lose that mark. Okay, so this will be 0.8 gram per centimeter cube. Now remember, this was GF and I wrote only grams, so this G I will not write. Understood? So our volume of the solid will be 4 gram upon 0.8 gram per centimeter cube. Gram got cancelled. 4 upon 8, and I'll write like this, and centimeter cube comes up here. 4 ones, 2s, 2 ones, 2 5s. What will you get? 5 centimeter cube. What is this? This is the volume of the solid. Must check if they're using the word block or solid and accordingly. So we got this. This will be for your 2 marks because it's a 4-mark question. What will we do for this? Relative density of solid. Now, they have said relative density, but tell me one thing. Do you know the mass of the solid in air? If 30 GF is the weight, then 30 gram is the mass, right?
Yes, ma'am.
So mass of solid will be equal to how much? 30 gram. Agreeable? And how much is the volume? Can you see that? So the density of the solid is equal to what? Mass upon volume, which means what? 30 gram upon 5 centimeter cube. That will be how much? 6 gram per centimeter cube, correct? Then RD will be equal to what? Density of solid upon density of water at 4 degrees C. So that will be 6 gram per centimeter cube upon 1 gram per centimeter cube. Do not do this directly. Show the steps like this. Okay, 1 mark for this and 1 mark for this. Understanding?
Yes, ma'am.
Okay. Now, what is the cause of upthrust? Again, the learning work. For this, temperature in Fahrenheit equal to or equivalent to 0 degree C. Do you know the formula between degree C and degree Fahrenheit? On which page it is? Come on, quickly look at it. C upon something. Which page it is on? Found it? Come on, look.
C upon pi equal to F minus 32 upon 9.
You can use this formula and use, correct? Hello?
Yes, ma'am.
Now for the second one they've given in Kelvin. So this will be, you will subtract 273. So you will get, that is 100 degrees C, correct? So
Yes,
100
ma'am.
degrees C will come out to be 212 degree Fahrenheit. Doing the calculations using that formula. I think you should be able to do that on your own. This is second law of thermodynamics. First law of thermodynamics is learning work. Aquatic animals can survive below the frozen rivers. Anomalous expansion, it is again learning work. Is the energy flow ecosystem cyclic or linear? This again is learning work. Can you see that? So you have to do learning work, loads of learning work you'll have to do today. Okay, let us come to diagram 1 and 2 are incident rays. 2, they are incident rays, and PQRS. Complete the diagram showing the optical object inside which is producing this effect. Now tell me what is happening over here. If whatever is over here, never mind if it is concave or convex mirror, it is going this way, and oops, you see it is coming this way. Can you see that? Okay, so the surface is here. What is happening? It is bouncing off like this. So it is producing divergent rays. So this is going to be which mirror over here? ISA. Which mirror this is? Which mirror this is? Tell me. You understood now how this is to be done? Yeah? And you have to show this principal axis here. Okay, correct? A test card optician situated 1.5 meter behind the eyes of the patient who is looking through the plane mirror 2 meters away from him. What is the distance between him and the image of the test card? Here you'll have to show the diagram. Can you draw the diagram? Show the horizontal behind the eyes of the patient. So this is the patient. We'll call that as patient. And this is the test card. Who is looking through the plane mirror 2 meters away from him. Now test card is from here to here. Show this as 1.5 meter. And from here to here 2 meters, there is the mirror. This is M, means mirror. Okay, so how much is this distance? Correct. So the image of the test card will be here. So this will be the image. Image of what?
Test card.
What is the distance between him and the image? Him and the image between P and this one. So what it will be? The distance between him and the image will be equal to PM plus MI. Understanding?
Yes, ma'am.
The 2, it will be 2 plus 3.5. But prior to that, what you'll have to say? That TM equal to MI, because object distance equal to image distance. Understanding? Okay, and prior to that again you will have to mention Tm will equal to Tp plus Pm. Understood? That will be 1.5 plus 2. Was it good enough? Tell fast. Good
Yes,
enough? Okay. Draw the ray diagram. How the shaving mirror. What is shaving mirror? Means it is the concave mirror, and where the object should be very close. Means object means the face should be between what? Correct?
Yes, ma'am.
And what kind of image I will get, you should know the characteristic. Virtual, magnified, upright, and behind the mirror. Which mirror is used as a rear view mirror? The convex mirror. 2. Practical uses, learning work. Object placed asymmetrically at an angle of 50 degrees. Find the number of images. Now asymmetrically. So what is your theta? Theta is 50 degrees. They say n is 360 degrees upon 50. This is giving as 7.2. Correct? Now, what is our rule? If n is even and if n is odd. Do you remember this? Go to that page. N is even, what do they say? The number of images are how much? Are n minus 1, whether it is symmetrically or asymmetrically, correct?
Yes, ma'am.
So if n is odd, now here you can see it is 7.2. So the number of images will be what? 6.2. So you will just write 6. Understood?
Yes,
Number
ma'am.
of images. We come to the next one. Essential conditions required, again learning work. In 0.4 meter, there are 20 waves. What does it mean? That 20 waves in 0.4 meter. So one wave in 0.4 upon 20 means how much? 4 upon 10 into 20. So 4 ones and 4 fives. This will be 0.2 upon 10, which means 0.02 meter. One wave in this. So what is this? Therefore, the wavelength is 0.02 meter. Did you understand this part?
Yes, ma'am.
So this is your answer to, but don't write lambda, write wavelength. Okay, so this is answer 1. 120 waves in 1 minute. So for the second part, we will say in 120 waves in 1 minute, which means 60 seconds. Correct? Yeah. So how many waves in 1 second? That will be the frequency, correct? Number of waves in 1 second will be what upon what? 120 upon how much it is? Understanding? Now we got the wavelength, we got the frequency. What is the relation between V, F and lambda? V is equal to, so that is 2 multiplied by 2 upon 100. Correct? How much is that? 4 upon 100. So 0.04 meter per second. Understood how it is? Are you able to do it?
Yes, ma'am.
Now look at this. N electrons through the cross section in time, E is the charge. Write the expression for the current. Current is equal to Q upon T, but Q is going to be N into E upon T. It's already there in the book. Define this learning work. How is it dependent upon area of cross section? Inversely proportional. More the area of cross section, less the resistance. Learning work. Amount of work done. So W equal to question mark. The charge is Q, which is 2 coulombs, and the potential difference V is 10 volts. What is the relation over here? V is equal to W upon Q, correct?
Yes, ma'am.
So they are saying work done will be equal to Q into V. Multiply and get it. Can you draw magnetic lines of bar magnet when north pole faces geographic north? What did I tell you? N, S, N, S, N, S and N, N, S, S, E, W. They are telling you this, correct?
Yes, ma'am.
So you have to draw the diagram and mark the neutral points according to what I told you. Is this simple? Tell fast. The current is, when this is shut, the current will go like this. So from here, if you look, this is clockwise. Can you see like this? It is going, means 3 o'clock, 12 o'clock, sorry, 9 o'clock, 12 o'clock, 3 o'clock. Can you see that?
Yes, ma'am.
So this will be the south polarity. So this will be the north polarity. Two long needles attached show the position occupied. Name the phenomenon that comes into play. What is happening over here? If this is north pole, the two pins are here. The pin will be like this attached. It will have north polarity induced on the opposite sides. Like polarity will repel and they will go like this. So what will you observe? That the pointed ends will be moving away from each other. What is the phenomenon? Magnetic induction. Okay, so we have finished each and every question, not just the choice questions, and we can stop here. Okay, all the best for your paper tomorrow.